This conference will now be recorded.
Okay, so we were discussing about the FP tree method of association rule mining. We had to use this method because of few drawbacks of the previous a priori algorithm. Okay, that we had to search the transactional database each and every time we have to create the candidate key. That's why we will be using this advanced method which was proposed by Joy Han. That's a leading data scientist or data mining expert. So this method was given by him. So in this method, what we will do, we will basically create an FP tree, okay, a tree-like structure, and on the basis of that tree-like structure, we will be able to find our frequent patterns. Okay, it is not that much difficult. It is pretty easy, but once you will understand each and every step, then only you will be able to solve the numerical easily. Okay, so be careful and just look at the steps very carefully. Okay, and I will just show you this algorithm by mean of an example only. We will not be discussing the steps theoretically. We will just see an example and then you will be able to solve that. Okay, so we'll start with the example now. Suppose this is our data set. It is better for you all to note it down, this numerical, because it will be needed later on in the stages. Okay, so this is the transactional data set which is given to us. 5 transactions are there and items are there. E, K, M, and Y, or these are the data sets items which are given here in each and every transaction. Okay, the minimum support count given to us is 3 and the minimum confidence given to us is 60%. Okay, so these are the variables given to us as the data set. We just have to find the frequent items and frequent patterns. Fine, so we should proceed. The first step is similar as your a priori algorithm. What was the first step? In the first step, what we had done, we had listed the different items which is given in the transaction data set, and we count the frequency or the support count of the individual item. So it is also same here. We will do the same step here only. We just find the individual items we are having in all these transactions and we will just count their frequency. Okay, so this is the first step. We counted all the items. These are different items, unique items, and this is their frequencies. Okay, A is appearing once, C is appearing twice, D is appearing once, E is appearing 4, and these are the counts for all other items. Simple. We just have to count the occurrences of these items. Fine. And what was the next step? Next step was to cut off the items which are lying below the threshold level of that minimum support count. The frequency of the support count is same. Okay, so we just have to now discard the elements which are not satisfying the condition of minimum support, and minimum support given to us in the numerical was 3. Okay, so what we have to do, we just have to remove the elements which are having the support count of less than 3. Okay, so next step is pretty much simple. We will just remove the items. So these will be the items left after removing K, E, M, O, and Y. Okay, we just remove the items, all the items which are having the support count or frequency less than 3, because that was given to us as the statement that the minimum support count is 3. So we removed all the elements having the support count less than 3. And we have to arrange them in the decreasing order of support. This is also an important step in this FP tree algorithm. You should remember it very carefully that if you arrange these items in some other order, then the final frequent pattern will be changed. Okay, so first thing is very important. You have to arrange these items in the decreasing order of their support. Okay, so K appears most frequently 5, then E, then M, then O, then Y. Okay, so this was the next step. We have to find out the elements above the threshold level and arrange them in decreasing order. Pretty clear? Okay. We are having also the elements which are having the same number of support. Okay, M is having same, O is having same, Y is also having same. So we had some method that we arrange them in the order of their alphabetical nature. Okay, that M appears first in the alphabet, so we arranged it first. O later, and then Y. Okay, these three are having same support count, so we arrange them in the order of alphabet. Fine. So now, what is the next step? Next step is this. Okay, so this was given to us, the transactions, and these are the items which were given to us. Now, what we are doing, we are just arranging these items and finding out the items which are lying in those frequent items. Okay, how we are arranging? The items we arranged in the previous slide was in the order of K, E, M, O, and Y. Okay, this was the order. So what we have to do, we just have to look in this transaction first for K. Okay, these were our frequent items. So what we have to do, we have to look for these items in these transactions individually. First, we look in T1 for K. If K is present there, yes, K is there, so we will write K here first. Okay, then we will look E in this transaction. If E is there, yes, E is there, then we will write E after K. Okay, then we will look for M. If M is there, yes, M is there, then we will write M. Okay, then we will look for O. If O is there, yes, O is there, then we will look for Y, then Y is also there. Okay, so like this, we will arrange our items in this ordered item set. This was given to us, these are the items. Now we will arrange these items according to our frequent items and whether they are lying in that order or not. Fine. Now again in T2 we will check like this. First we will search for K. K is there or not? Yes, K is there. So first we will write K. Then we will search for E. Is A yes there? Not E is there? Yes. Then we will write E. Then we will search for M. Whether M is here? No, M is not here. So we will not write M. Okay. Then we will check for O. Yes, O is there and Y is also there. So we'll write it like this. Clear? We just have to look for these items in these and arrange these according to this only. Okay, I think it's clear that we have to arrange these items according to these frequent items. Fine, so we should proceed. Now, the next step is to arrange these items in a tree-like structure. Okay, we have to arrange these items. In transaction T1, it is KEMOY. So first we will consider this one, KEMOY. One by one, we will arrange all these ordered item sets into a tree-like structure. Okay, so first we will start with KEMOY. Okay, so how you will arrange this? This step is important, so look at it very carefully. Okay, so first we'll start with null. Okay, then the first item in that order is K. We'll write K, then it is E. Just have to look at this. Okay, we have to just look at this set. Fine. We added K, then E. Okay, then we will add M, then O, then Y. Okay, or what this is what the number of times these items are appearing, we will write that. Okay, till now these items appeared only once, so we will write 1 alongside each and every item. Clear? Until now there is no doubt. Okay, so we added this pattern KEMOY. Now next step is to add the patterns of transaction T2, the frequent item set of transaction T2. So that was KEOY. Okay, so that was KEOY. So now we have to add this KEOY in this tree which we had built previously. Okay, and what we have to take care of that the items which are already present in this tree, we do not have to redraw those items again. That thing you have to take care that K, starting with K is already here. Okay, then E is already here in that same pattern after K and then E. Okay, so K and E appear here together, so we do not have to make another node for K and E. Okay, what we will do after K and E, what is there? O. So here what it is, after K and E, here it is M. So it doesn't match with our pattern. So after this we will add one another node. Clear? From E we will create one another node as O. Okay, because after K and E it was O, and now what happens? We added O, it's okay. The count of O here is 1. Fine, because this O is appearing only once. But K and E, the count for K and E will be now 2. Why? Because those were because of the first pattern KEMOY. Now we had increased the count of K and E because of this KEOY. Okay, so in this slide also I have made as K as 2 and E as 2. Okay, then one other element Y is also there, so we will add Y also, and we will join them in the same alignment also. It does not have any changes. We will not increase the count of O here and Y here, although they are appearing twice. So we will not increase because we had made another node for O and Y. They are linked to the initial O and Y, but we made another node with 1. That's why we do not increase the count of this O and Y. But K and E we used the previous one. That's why we will just increase the count of K and E. Fine. In the same way, we will insert all the frequent item set in this FP tree. Okay. Next item was KEM. So we will insert E and M here. So what will be the changes? K, E, M, these elements are already there in the tree in the same order which is appearing here. So we do not have to create any other node. What we have to do, we just have to increase the support count for these variables. K was 2, E was 2 and M was 1. And by this item set KEM, the count for KEM both will be increased. Okay, for these 3 elements the count will be increased. The count for K will be now from 2 to 3. The count for E will be now from 2 to 3. The count for M will be now from 1 to 2. That's how we inserted this KEM here. We do not have to create any new node for this item set KEM because it is appearing in that frequent tree in the same manner it is appearing in our frequent item set. Okay, so now we will just introduce another element, next transaction, that is KMY. Okay, so K is as the first node is always here, so we do not have to create K again. What we will do, we will just increase the count of K by 1. It was 3 previously, now it will be 4. Okay, then after K, what is here? M. But in this tree, it is KE. Okay, so E does not match with our pattern given here. So what we have to do, we have to create one another node after K. So we will create M here. Okay, and link it with the previous one M. Okay, and the count for M is 1, and after M what is here? Y. So Y does not matches with this pattern anywhere else, so we will again create another node as here. So this will be a new pattern KMY. Clear? It is not very much difficult. We just have to take care whether to increase this item count or not. Okay. If we by mistake forgot to increase the count, support count here, then it will all go wrong. Okay. So I think one more pattern is left. Okay. KEO is also there. So we have to insert KEO also. So K was there and E was there, both were there in the same pattern, so we will just increase their count. We do not have to make any other new node. K will be now 5, E will be now 4, and what is their next? O. And in this previous pattern KEOY, we have this in the same node. So what we will do, we will just KEO, we will move in this pattern, we will find our KEO pattern, and we will increase the count for O by 1, so it will be 2 here. Nikita, it is not possible. Better to repeat the complete tree part. Okay, I'm creating it as a video. You will be able to see it later on. Okay, so it is up to KEO. I think all of the patterns are now in the tree. So this is the first step. What we have to do, you have to insert all the patterns in the tree. Okay. Now what you have to do, just look at it. It is the final tree which is there. Now you have to check according to your transaction which was given to you, what is the item set you get. These were the items, frequent items that you identified, KEMOY. Okay, now write those items in a list in the increasing order of their frequencies. Okay, you just write those items in the increasing order of those items as frequencies. And what you have to do, you just have to traverse those items in this tree starting from this and find out the elements which are there. Okay, so how you will do that, I will tell you. Okay, so the first item is Y. Okay, so how you can create Y, you have to write here. Okay, so first we will start from here. So if you traverse back, the path is O, M, E and K. Okay, if you start from null to reach Y, what you have to do, K, E, M and O. This is the path you have to follow if you start from null to reach this Y. Okay, so the conditional pattern for this Y will be KEMO, and which is written here as KEMO colon 1. Colon 1, 1 is the support count for this Y. Whatever the count here of this Y, you just have to write that support count here in this conditional pattern base. Okay, now this Y, we have two other Ys also. So for this Y, what is the root starting from the null? The root is K. We will start from here, K, then we have to go here, E, then we will go here, O. Okay, then we will reach here. So what is the path? It is K, E, O. That is the second, K, E, O. And the count will be again for K, E, O is 1 because 1 is written here. Fine. For this Y, it will be K and M and directly Y. So the path for this Y will be KM and the count will be 1. Okay. Similarly, for all these items, we will create these conditional pattern base. So once again, we will check for this also. So for this O, what will be? For this O, first it will be K, E, M. So it is here written here K, E, M. Okay, and the count is 1 here. So it is written 1. Fine. Next O is here. So to reach this O, what is the path? K, E, and directly to this O. So the path is KE, and the count written here, that is 2, because the count written here for this O is 2. So the path KE has the support count of 2. Okay, so there is no other O occurring here in this FP tree, so O is over. Next we will check for M. M is here. For reaching this M, we have the path as KE with the count as 2. For reaching this M, we have the path of only K with the count 1. So we'll write both as here. For reaching E, we have only single path starting from K, and the count will be 4. That's why it is written here 4. Okay, and K is having the first element. We do not have any conditional pattern for K because it is the starting node. So that was the next step after creating the FP tree. So what we are doing here, we do not have to look at the initial table again. Once we found our elements, okay, we do not have to check the initial table. We just have to check this FP tree, and from this FP tree we are creating this conditional pattern base. Okay, the initial transaction, you do not have to take care of that. Okay, so there is only one step left in this. After this, what you have to do, you just have to count the elements which are appearing in all these conditional pattern base. Okay, you just have to count the elements here in these, and you just have to write the conditional frequent pattern tree items which are appearing in all these sets. Okay, so for Y, what is the element which is appearing in this set? K is here, K is here, and K is also here. None of the element is appearing in all these three apart from K. So we will write K, and how many times it is appearing? 1 plus 1 plus 1, that is 3. So that's why the conditional frequent pattern tree for Y is K with frequent count as 3. Okay, for O, these are the two sets, and what is the item which is appearing in these two sets? That is KE is here and K is also here. So we will write KE, and the count will be 2 because the count given here is 2 and plus 1. So count for KE will be 3. Okay, and here it is for M, K is appearing here, K is appearing here. So we will write K with count 2 plus 1 as 3. And for E, it is only single set, so we have to write it here as K4. And for K, we do not have any conditional frequent pattern tree. Fine. So this was the last step. Now what you have to do, now just you have to create the rules, and rules will be created like this. What we have done here for Y, if you remember the previous slide, what we had done for Y, the frequent pattern selected was only K with count 3. Okay, for Y the item was selected as K with count 3. So for Y the frequent patterns will be K comma Y with 3. Okay, and for O the frequent patterns was selected as KE with count 3. Just look at the previous slide, it was for O selected as KE with count 3. Okay, so for O the frequent patterns will be combination of all those items, that is K, E and O should be there each and every time. So one pair can be KO with count 3, one pair can be EO with count 3, one pair can be all the elements KEO with count 3. Is it clear? This is the last step. After this, you will just generate the rules. Just look at it. We created these conditional frequent pattern trees. Okay. So for y, we are having only item k. So for y, the pair will be k comma y with count 3. Okay. For O, we are having the elements k and e with count 3. So the pairs for O will be k o. Okay. One will be e o. Okay. One will be k e o. These will be the patterns or pairs corresponding to this element O and this pattern. Okay. For M, we are having only single element k. So the pattern pair for M will be k comma M. Okay. So with E, we are having only k. So the pair with E will be E comma k. So that's why that is the step we are doing here. So these are the final pairs which we get after the FP tree method. Now we will create the rules. The rules will be like this: k tends to y or y tends to k. One rule can be generated from this first pair: k tends to y or y tends to k. Second, from this the rules can be generated as k tends to o and o tends to k. Okay, or e tends to o tends to e. And from these three it can be e tends to k o, or k tends to e o, or o tends to ek, or all the other methods we had seen for creating the rules in a priori method. You just have to create the rules from these pairs, and according to the minimum confidence level for the rules, you just have to check the rules which satisfy that condition, and you have to discard all other rules. So that was all about the FP tree method. Okay, so for now it's enough. We'll try to solve another numerical in the next class, or if you're having some doubt, you can ask also in the next class also, or today itself. For now, for those who got this, the class is over, you can leave.